Yesterday we learned how to calculate mole to gram calculations and gram to mole calculations, and also going from moles to our representative particles and back again. So those were our one-step conversions. We're going to continue on, and now we're going to look today at our two-step conversions. And really all we're doing is we're putting together those two separate one-step conversions into a two-step conversion. So today we're going to focus on going from mass to representative particles. Remember, our unit of mass is grams, and our representative particles are going to either be molecules, atoms, or formula units. Now let me just remind you, molecules are specific to molecular compounds like carbon dioxide. Atoms are specific to elements like carbon. And formula units are specific to ionic compounds like, for example, sodium chloride. When you read these word problems, one thing you will not see is you will not see the word mole mentioned in the problem. So that's how you'll know it's a two-step. Remember yesterday I told you a hint was when you read your problems, if you see moles, you know it's a one-stepper. Well, in this case, we're not going to see moles, so it's going to be a two-step problem. Let's look at both of the plans here. Plan 1 simply is a format for those of you that maybe are not as mathy as others, so maybe you need like a template to follow. So refer back to this if you get stuck. This involves going from mass of A to representative particles of A. A meaning whatever substance you start with is the same substance you end with. So in this case, you would obviously begin with your given. It would be given in grams of A. So we need grams of A to cancel. That means molar mass is the conversion factor to use if you need grams to cancel. Molar mass is the grams per 1 mole, remember. So you need moles to cancel, moles of A. We'll go on bottom, and you're trying to find the representative particles, so that will go on top. 6 times 10 to the 23rd representative particles equals 1 mole. As you would be working through this particular type calculation, let me just show you how your units all cancel. So grams of A cancel with grams of A, moles of A cancel with moles of A, and you're left with your representative particles. All right, we'll look at an example worked out in just a second, but let's look at plan 2, which is if we were to go backwards from what we did in plan 1. So if you were starting with your representative particles of A, like atoms of A, or formula units of A, or molecules of A, and trying to go to mass of A, this is what your setup would look like in this case. So your given would be the number in the problem given with the representative particles. So you need representative particles to cancel. That means Avogadro's number goes on bottom here. And we know there's 6 times 10 to the 23rd representative particles in 1 mole of any substance. This would let your representative particles divide out. And so now moles need to cancel. So you put mole on bottom, mole goes diagonal. 1 mole goes on bottom, grams on top because you're looking for grams. Whatever you're looking for, that unit is the last unit standing right here. It's the only one that doesn't cancel. So of course you would calculate your molar mass and plug it in here. All right, so let's go through a couple of examples. Now, the problems that I'm doing come from the worksheet we used in class yesterday. The title of the worksheet is 10-2 Practice Problems. And this is number 16. We're also going to do number 17. Okay, so let's start off here. When you're doing a word problem, a calculation, I find it helpful to underline the knowns and the unknowns. So that's what I'm going to be doing here. How many formula units, oh, that's important. These are your representative particles, are in 3.5 grams of sodium hydroxide. So of course we're going to start with our given 3.5 grams of sodium hydroxide. Remember, for the problems that we're doing, nothing's typically going to go underneath the given. Now, I would come all the way over here just to kind of help you set it up, and we're trying to find formula units. So I'm going to put formula units here, and this is sodium hydroxide again. So we're staying with the same substance. This is what A is in my format we looked at in the notes a second ago. Now, remember, look at your units and analyze them. Grams here, formula units here. We do not see moles, and that's how I know this is going to be a two-step problem. So the first unit I need to cancel is grams of sodium hydroxide. So this is the molar mass, and that's going to always have 1 mole opposite that. So we need to calculate the molar mass. So I'm going to come over here. We got sodium, we got oxygen, we got hydrogen. So sodium is 22.99 grams per mole, oxygen is 16.00 grams per mole, and hydrogen is 1.01 grams per mole. Of course, all these come from your periodic table. When you add all this together, you get 40.00 grams per mole for your molar mass. So this molar mass plugs in here, and this is going to let grams cancel. Now we need moles to cancel, so bring moles on bottom here. And remember, in all the problems that we're doing in Chapter 10, moles will always have a 1 beside of it. Just remember that for the Chapter 10 problems. So we need formula units on top, and this is where Avogadro's number goes. 6 times 10 to the 23rd formula units equals 1 mole. This allows moles to cancel. So now we're going to plug this in. I always multiply the whole top row together, so 3.5 is how I plug it in, times 6 EE to the 23rd. Remember to plug it in correctly with your calculator and scientific notation using your EXP or EE button. Then say divided by 40. And we have 2 sig figs in the given and 4 sig figs in the molar mass. And Avogadro's number has unlimited sig figs, so that's not going to be a factor in our significant figures of our answer. So we need to round our answer to least sig figs when you multiply and divide, so we need 2. So you should round this to 5.3. And that's going to be times 10 to the 22nd power. All right, that's number 16. Now, let's look at number 17. 17 says, if you burn 6.10 times 10 to the 24th molecules, again, these are our representative particles, molecules of ethane, that's a hydrocarbon, so this is a combustion reaction. What mass of ethane did you burn? Well, let's start with our given. As usual, 6.10 times 10 to the 24th MOLEC of C2H6 of ethane. Okay, come over here and we're trying to go to mass. Remember your unit of mass is grams, so C2H6. All right, we don't see moles, we see molecules in grams. So that's how we know it's 2 steps. So you need molecules to cancel. Remember, get your units to cancel. Molecules go on bottom of C2H6. This is going to be Avogadro's number. There are 6 times 10 to the 23rd molecules in 1 mole of any substance. In this case, C2H6. This lets molecules divide out. Now we need moles to divide out. So bring your mole down here. And this will be grams. So 1 goes beside a moles again. So we need to find our molar mass and plug it in here. So we have 2 carbons times 12.01, that gives you 24.02, and there's 6 hydrogens times 1.01 gives you 6.06, and when you add that together, 0, 10, we get 30.08 grams per mole. So this molar mass plugs in here, 30.08 grams per mole. This lets moles cancel. All right, now you're ready to plug it in because you see here that grams is what you wanted, and that's where you're at. So you're going to multiply the top row, 6.10 times 10, that's second comma. If you have a Texas Instrument, second comma to the 24th, you're going to say times 30.08, and then divide that by 6 EE to the 23rd. And we're going to round this. This has 3 sig figs here. This has unlimited sig figs. This has 4 sig figs. So we're going to round our answer to 3 sig figs because this is our least sig figs. So we would round that to 306 grams of ethane. All right, that's our lesson on our 2-step conversions. Problems 18 through 22 on this same worksheet are part of your homework tonight. They will be done just like 16 and 17.